Welcome to a talk with Ray Tomes of the Cycles Research Institute. Ray is going to tell us a little something about the monsoon cycles of India. Ray, thank you for this. What can you tell us about the monsoons?
Yeah, I'll mention here, in case I forget later, another one of our advisors for the Cycles Research Institute, Gupta Shyam, I hope I'm pronouncing his name correctly. He's done a study of long-term things relating to the monsoon cycle and long-term climate studies, and that's quite an interesting one as well. So that's something else to refer to in relation to this.
Yes.
This graph is showing from about 1948 through to 2000, the rainfall in India, and you'll see each of these peaks is a year.
Yes.
And what happens is, in India, more or less, it doesn't rain for 8 months, maybe a couple of sprinkles here and there, and then for 4 months it does nothing but rain.
Wow.
That's the monsoon.
Yeah.
It's a very extreme climate for what people that live in countries like you and I do, where you get a bit of rain through the year. There may be a season where there's a bit more, but it doesn't just rain continuously like this.
No, it does not.
But you will see that, having said that, there's some ups and downs. It doesn't rain the same amount every year, and the date it arrives is fairly uniform, and it sweeps across the country in a few days, when it arrives.
Yeah.
And so all that stuff is known and studied. I'm not going to talk about that. There's other people that are much more expert on those things. What I'm going to look at is these variations and what else data is hidden in here once we get past this extreme cycle of the year.
Yeah.
This is a spectral analysis using that data that's there, and it shows us here we're going from the number of the frequency of the cycle, and I've labelled in years the period that is determined by the analysis with cats, and it says the fundamental cycle is 1.0001 years. So in other words, it's a year.
Yeah.
Pretty accurately. That's about as accurate as you would hope to get with 50 years of data.
Yeah.
It says there's other cycles of a half a year and a third of a year.
Yes.
In other words, the shape of the thing
Yeah.
is not a sine wave. It's got some harmonics in it. The shape is much more pointed at the top, and so we get these other ones, and there's probably other ones at a quarter and a fifth and so on. We do see some other ones, a couple of secondary peaks each side of these, and so these ones, we can see that one's 0.027 less, and that's 0.028 more. And that means those will make beats with this, and the reciprocal of 0.028 is about 36, 37 years. That's saying there are some beats. There is a longer cycle in which the yearly cycle is fluctuating.
Oh, okay.
And these things are saying the same. And then there's a couple of other little rogue ones here. We see these other things that have got different periods here. Are these real? Well, yes. Generally, I just put in here the ones that have got a significant. We'll see there's a 19-year cycle, a 7-year, a little less than 5-year, and a couple of other ones just over 2 and just under 3 years. So there are some other cycles present, but it's a bit hard to see those with that very strong annual cycle.
Yeah.
Because the cycle is lopsided,
Yes.
the fluctuations when the rainfall is high are much greater than the fluctuations when it's low. I've taken the square root of the rainfall. That has the effect that the lower end gets expanded and the upper end gets compacted.
Okay.
So it becomes more of a similar fluctuations at the high and low end.
Because the changes at the low end are much smaller than the changes at the high end.
So we're trying to. So this process allows us to look at shorter term cycles that may be passing right through the seasons that exist. So that's the first step, and then with the seasonal variations removed. So at that point, I then take the average annual cycle that occurs throughout the whole thing, and I take it away from it, and this is what we end up with. So now there's not so obviously anything going on, although we see an odd thing like that looks about the same distance as that. Maybe it's not, but there's some it's something we can look at now for other cycles than the ones strictly related to the year.
Yes.
And this is now a spectrum of that previous graph.
Yes.
And it's ranging from it's in the monthly data, I think, isn't it? So, but what this is showing is a series of cycles. The blue ones are in days, and the red ones are in years. So we do see there is a 19-year cycle and a 7-year cycle, and a few other ones, 3.86-year cycles there, and then these other ones in days. Now I've marked 4 of them with a little green arrow.
Yeah.
And the reason is that these are cycles that are seen in other things, particularly the sun. I showed you in that previous one, there was a cycle of a little over 600 days, 300, 150 something and 75 were present in that magnesium ratio in the sun.
Yeah.
Here we're seeing exactly the same cycles. This is the first time I've found them on something relating to the Earth.
Yes.
Before that, they were just known as solar cycles, found in many things in the sun, but this is found now on Earth. So 75.75 days, 153, 303.5627, and this is pretty close to a doubling.
Yes.
Pretty close to a doubling. Pretty close to a doubling.
And clearly coinciding with the solar years.
Solar cycles.
Cycles.
And there are some other ones here. There's this one, and this one that aren't part of that pattern, which are significant cycles also. So that's the hidden inside some data, which has got one extreme cycle that tended to mask everything else. If we process the data right to remove that one,
yes,
and to make it so that cycles happening during the very dry period where they're very, very small,
yeah,
and during the very wet period where they'll be very large. By pre-processing the data, we can allow those cycles to proceed right through. Now, the guys that were finding the 154-day cycle in the solar data,
yes,
were reporting. They would make a report during cycle so and so, and they were looking at it during the maximum of the cycle and not during the minimum. But what I found is when I did the same sort of square root thing on the sunspot numbers,
yeah,
and then plotted it, you could follow them right through the whole lot. So it would be there. They would find it in that peak and that peak. You could trace it through the troughs as well.
Because you magnified the low changes, the small changes at the low.
And it could be seen throughout the whole thing then.
Yeah.
So this sort of processing of data, some people might think it's some sort of fiddling. It's not. It's who's to say what it is you measured. If you measured the area of sunspots, who's to say you shouldn't have measured the radius of them, which would be the square root of the area, right?
Yes.
So who's to say that that's what you should have measured or shouldn't? Transforming data, it's not creating new cycles. It's allowing you to see what's already there.
Just a magnifying glass.
Yeah. And so and again, these other cycles like 19 years, we know 19 years is connected to the moon. That there's a lot of cycles related to the moon in that vicinity. And so
would that be the tilt of the orbital plane of the moon, or how close it is to the Earth?
Yes, it's if that's the plane of the Earth's orbit,
yep,
and the Earth's equator is at this angle, 23 degrees,
yep,
then this is the wobble of the moon's orbit about that.
Yes.
So its tilt relative to the Earth's orbit is getting larger and smaller over that sort of cycle.
Yes.
But there's a number of other ones that happened over that period as well. There's a coincidence of cycles around that. There's that's 18.6 years, the one I described. There are a couple of cycles very close to 19 years, which are where a number of other things all come together. The eclipse cycles, is it the Saros?
Saros cycles, yes.
It's 19 years and a little bit. So there's a bunch of things around that 19 years. From this, we can't say which of those it is. If we had longer data, we'd get a more accurate figure on that, and we could say, oh, it's 18.6 or it's 19.0 something, or whatever. Alternatively, we could also look at the phase of that to see what it's fitting in with, Yeah. So those things would be further clues, further investigation to look at those. There may be some other clues in these other periods as well. I think that's... that's it. So that's a relatively simple thing, but with a couple of things that people don't commonly do, like this transformation, and the removal of the very, very strong cycle allows us to see other stuff that's hiding underneath it there. And in this case, it does appear that something that's happening on the sun is also happening on the Earth that we didn't previously know that was happening on the Earth with those harmonically related cycles. And that pattern, I expect that we will find it other places than the Earth and the sun.
Well, with good analytical
as time
methods,
goes by.
we may, indeed. And this certainly works. And like you said, you didn't change the direction of the data. You just put a magnifying glass on it where you had to just be able to look at it without other things getting in your way. It's just sort of like putting sunglasses on to remove the glare so that you can see better in the shadows.
Yeah.
So
that's that one.
Ray, thank you for explaining that to me. Seasonal variations in India and rainfall, and analyze those.
This here is a graph of cosmic neutrons arriving at the Earth. we can see that this is a period of 55 years, and we can see 1, 2, 3, 4, 5 cycles. So about 11-year cycle in cosmic neutrons.
Sure.
It's obviously affected by the sunspot cycle. It's an effect of the sun. Any particles come from outside the solar system, the sun modulates them because it's the solar wind gets
blocks some of the cosmic particles.
Gets bigger and smaller, yeah. So we've got that, but it's interesting that that's at this end that it varies more than it does at this end. It's the opposite way up to the sunspot cycle.
Yes.
So that's the graph of the number of neutrons arriving from the cosmos.
Yes.
And then we can do a spectrum of that, but in this particular case, I've just picked out a narrow part of the spectrum from about 20 days through to about 40 days. And in the middle of this, we find the period around 29 and a half days, which is the period between full moons.
Ah, yes.
And the two biggest peaks in here are at 29.483 days and 29.587 days. The probability that that these would occur by chance are 0.000029 and 0.00065. So we can say these are very real cycles.
Yes.
All of these red ones are significant by the test of 0.05 probability, which means a majority of those are probably real cycles as well. Very, very complicated structure, which I'm not going to try and unravel all of that. But I will say these two are notable because the actual period of the moon around the sun is 29.53 something days. One of those is 0.05 something more than that, and the other one is 0.05 something less.
Yes.
Now, what does that mean? It means that we get beats between these.
Yeah.
If we just consider the beats between these two, 0.103 days, we can divide that in there. It says there's about 0.104 days. It says there's about that it takes about 280 cycles of a lunar month, which means it's about 23 years. Now we've got about 50 years data, so we're not going to be super accurate on that. But what do we know that happens around there? We do know that the north and south pole of the sun reverses every 11 years, which every 22 years they come back to the same place.
Yes.
So that's going on. Now, what this is saying is that the moon is having an effect on these neutrons coming into the Earth. Is it a magnetic effect or something? No, because neutrons aren't affected by magnetism. What is it? Some effect, but it must be somehow related to magnetism because the sun's doing this flip-flop, and that's modulating the moon's effect on these neutrons. So we've got this complicated thing. It's not clear because neutrons are neutral and they shouldn't be affected by a magnetic field. Hang on. Yeah, they're not really affected by a magnetic field. Electrons and protons curve opposite ways, but neutrons just go straight through. So it may be that the neutrons came from something else that decayed along the way or something, I don't know. But this is very clear that these two periods mean that there's a modulation of the lunar month, very accurate period for the lunar month, modulated by the solar cycle. Not so accurate for that because we've only got to just over full solar cycles of 22 years in this. So we haven't got that period very accurate, but it would seem to be the case that it's that. So a longer period of this, there may not be longer periods because it's probably only measured since then, but we have got another 10 years since then, since this was done. So cosmic neutrons relate to the moon and the solar cycle.
Indeed.